Hello again, and welcome to the 10th Near Protocol Workgroup Call. My name is Victor, and it's really great seeing you all here again today. Really excited for us to look at NEP-539 and 522. So this is our agenda for today. First, we'll look at the objective for the call, and next we'll introduce everyone that's involved, and then we'll get into the main conversation of NEP-539, and then move on to NEP-522. After that, we'll talk about the implementation and open it up to Q&A. So hey, if you're new here, feel free to introduce yourself in the comments and drop any questions you may have. And now let's take a look at the objective for today's call. So we're here to publicly vote and arrive at a verdict for NEP-539 and NEP-522. We're also here to celebrate the time and effort that everyone has invested into this NEP. And in this process, there's four key roles to NEPs. There's the author, who is the person that writes the proposal and presents it to the work group. There's the moderator, who facilitates this process, the reviewer, and approver. Now, very quickly for everyone new here, to visualize this process, there's three phases: the draft, the review, and the voting, and two possible outcomes: approved and rejected. All the roles I mentioned previously help move the NEP through these phases and towards the outcome. When we do get to the voting phase, the work group has an open public discussion to arrive at the best decision in a transparent way, which is why we're here today. So yes, before we jump into the NEP review, I would like to quickly highlight the authors of this NEP. We have Jakob and Walclaw. We have Jakob on the call today, who's the author of NEP-539. Thanks so much for your hard work and submitting this NEP. I'm playing the moderator role in facilitating this call. And now let's have each workgroup member briefly introduce themselves for first-time listeners on YouTube. Marcelo, would you like to go first?
Yes, sure. Thank you, Victor. So, hey, everyone. My name is Marcelo Fornet. I was working for NEAR on the protocol team some time ago. For now, I've been these last few years working on the protocol group, reviewing all proposals for NEPs. Excited to be here.
Awesome. Michael, you're next.
Thanks, Victor. Hi, everyone. I'm Michael. I used to work for NEAR Core as well. These days, I'm at Aurora doing protocol work with them and still occasionally contributing to NEAR Core. But yeah, very happy to be on the working group here talking about protocol changes. It's very, very exciting.
Awesome. Marcin.
Hi, I'm Marcin. I also used to be a protocol engineer at NEAR, and currently I'm working on zk-Sync and Ethereum.
Nice. Bowen, you're up next.
Hey, everyone. I'm Bowen, head of protocol NEAR, and yeah, working on protocol research and development. I'm happy to be here.
Awesome. Okay. Great. All right. So now I'd like to invite Jakob, one of the authors, to share a summary of this NEP. Jakob, the floor is all yours.
Thank you, Victor. Yeah, just very briefly for those who are kind of confused why I'm here, why I'm not here. I used to work for Pagoda full-time in the protocol team. Nowadays, I'm working with the same people in the same team as a contractor for this specific project. So this is currently the only thing I'm doing in the ecosystem, but I have been kind of in various discussions throughout the whole time, even when I was not in any contractual obligation. But this is one thing that I've put a lot of time in. Me and Václav spent the last 3 months working hard on this, designing, simulating different congestion control strategies. And this is kind of the final bit that I'm going to explain here. I don't have much time, so I will just give a very brief overview here. And I assume everyone with voting power in the call did already read the details and kind of knows what's happening. But for everyone else, today congestion is a problem. When too many receipts, too many transactions come in, we don't have a way of dealing it properly when it comes to cross-shard communication. So this slide here shows that RPC nodes just always accept new transactions. In the transaction pool, we have some limit, how large it can grow. But then shards just always take new transactions in no matter what. But they can only execute a certain amount each chunk. So it might happen that they accept more than they can chew. And in that case, delayed receipts queue just keep on growing and growing. And you have to imagine like shard 0 can accept a transaction, and that produces a receipt, which then produces another receipt for shard 2. And there is absolutely nothing limiting it. And yeah, kind of the triangle here, delayed receipts queue can grow without limits. Now, can you go to the next slide, please? This is what we propose to change. We add a bunch of outgoing buffers for each shard. And kind of the red text show as well the changes that we want to see even on the transaction pool level. So very briefly, the outgoing receipt buffers are used to ask the other shard first, do you actually have space to accept these transactions? If your delayed receipt queue is already too long, then maybe I will keep it here on my side on the outgoing buffer. That gives better properties for memory usage of each shard. And then we compute the congestion level for each shard that depends on this outgoing buffer, as well as the delayed receipts queue that already exists, plus a sum of all the memory bits we use to store these receipts. Kind of the summary of all of this gives a congestion level between 0 and 1. And based on this, we also make decisions on the transaction pool level. When we see that new transactions are in there that are targeted towards a shard that's fully congested, then we just drop it and say, like, this shard has too much work already. Let's not keep this here. It will take a long time before it's executed anyway. Let's just tell the user we're dropping it. Now, this is only a protocol level specification. So we're not actually telling what RPCs are doing. We're just saying, like, on the protocol level, we will drop them and we will not accept them. But we want, as here written in like the top box, reject transactions to congested shards on RPC nodes. We want that to happen already there. It's not part of the specification, but that's how it's intended to use. And we provide all the information in the chunks so that RPC nodes have the information that now they shouldn't be accepting any new transactions to these shards, and they can already drop it there. And then we will get all these limits kind of on these different levels. We have these different limits, and in the end, we hope that that reduces congestion that piles up in the system, and hopefully everything is more stable. And if you go to the next slide, please. For users, this is kind of what they see. Instead of waiting for a long time and not knowing what's happening, they will either get a fast execution, or they will know quickly that their transaction is going to be rejected now. They can retry and maybe in the future add transaction priority, but that's not a part of this yet. We can also put, like, explorers can decide to show these congestion levels. These are this information that's available. You can look at how congested is the system. And yeah, kind of one downside here is now it becomes visible that depending on which shard you are on, if you're on the same shard as a BC contract, then you share the same congestion prevention problems that this shard has because of the BC account. And that's it. Yeah, that's the summary of what's going on. I'll give the word back to you, Victor.
Awesome. Thank you so much for your summary and for submitting the proposal, and yeah, all your ongoing work, of course, throughout this process. It's really great to see. Okay, the community has reviewed and discussed this NEP on GitHub, along with the workgroup members. So next, I would like to invite Bowen one of the reviewers, to summarize the advantages and concerns we saw in the comments. Bowen, you're up.
Yep. So this NEP is definitely a major step forward in terms of addressing the issues under congestion. It gives a much tighter latency guarantee for users who submit transactions when there is congestion. So the idea, as Jacob just mentioned, is that you either get your transaction executed much faster, or you know it's going to be executed within some specific amount of blocks, or your transaction that get rejected right away, so that you don't you don't get stuck in some kind of limbo state for very long. Yeah, this also kind of helps us handle the not just like within a shard, but for the entire system. And it's a great improvement over what we have now. Now, regarding the limitations of this proposal, I think one is that there is no theoretical bound on the receipt buffer sizes. This is due to the different trade-offs that we have to make. It is possible to have this theoretical bound, but then it would make other things suffer, like the throughput of the system, for example. So we impose basically a soft limit that in experiments have shown to work very well, and would improve the throughput of the system under congestion. This user behavior change, or this behavior change of how transactions are handled, is another point of concern. Yeah, I mean, it's something. It is a behavior change that people have to deal with. But I think it is actually a positive change, because I think people would rather know the transaction failed when they submit it right away, rather than wait for an indefinite amount of time. Yeah, finally, this solution is definitely not very simple, and it introduces more queues and changes to the state, and also chunk headers and things like this. And it needs to be maintained going forward. But I think the trade-off is worth it. I think the improvement it brings to the protocol is definitely very beneficial to everyone in the ecosystem.
Excellent. Thank you so much for sharing. And great. So now that we've heard about the benefits and the concerns, let's take a look at each working group member's opinion, which brings us to the voting phase. Okay. So based on the NEP process, we need a 2/3 majority to move forward with this NEP. And we've already had each work group member provide their voting indication on the NEP itself in GitHub. So here's the summary. So yes, we actually had all 4 working group members leaning towards approval of this NEP. The slides will be updated right after this call. So before we formalize this decision, I'd like to ask if any of the work group members have any final comments or concerns they'd like to raise. Yes, Marcin.
Yeah, so first, this was a large change. So, I mean, big kudos for getting such a monster design doc and implementation going. The only con in there that you probably mentioned, Jacob, is that if someone's unlucky, they keep being unlucky, right? Like if you end up on the shard with a very popular DApp, like you're stuck, period. Like almost all of your transactions are going to be rejected if this DApp fails. And that's why I'm stressing this is very important that users can easily see it on the explorers. They are affected, and potentially giving them a way or an idea how to get out of the situation if this happens for too long. This may be a pathological case that, again, in reality, we hope that it will not happen too many times, that such drastic things will happen. But again, for users, it can be very frustrating. So we need a good interfaces for them to be like, hey, whatever, exclamation mark, yellow thing on dashboards or in different places where they can use near, right?
Awesome. Thank you so much for sharing that, Marcin. And yes, congratulations, Jakob. Okay, next I'd like to invite Jakob again to speak on the implementation of this NEP. Jakob, you're up.
Okay, yes. So the implementation status is we're done with the logic. Like we've implemented everything already to the point where it's merged to near core behind the feature flag, but we're still working on the last integration tests, and we're still working on benchmarking the system on a higher, like testing it in lab environment is one thing, but this is about congestion. We have to actually spin up a full network, put it on the real load, and see how that works. So yeah, we're still working on that, and we expect this to not to be the majority of the work to be done, but still possible that certain problems come up as we test it and stress it further. Yeah, I think that's pretty much all I can say about the implementation status. There's a project tracking issue on the near one board. You can also take a look at that, and I keep updating that with the latest status with all the details and linked issues.
Awesome. Thank you so much for that. So now that we're done with NEP-539, we can move on to the conversation topic that is NEP-522. Okay. All right. I would like to call upon Michael to share some of the benefits and concerns of this NEP. Michael, the floor is all yours.
Thanks, Victor. So first off, I think we're all on the same page that we do want something to be done about nonces, like the state today where you can be sending multiple transactions and have only some of them get through because of the way, like if transactions get reordered and a higher nonce gets in first, it could prevent earlier transactions with lower nonces from being accepted afterwards. And this is a pain that shows up basically whenever you end up with an application that sends a significant amount of transactions. So usually the way we suggest people solve this is to add more access keys. This is one of the cool features of Near as a platform, is you can put in more keys on your accounts, and so now you don't have that nonce contention. But it doesn't fully solve the problem, and adding more and more keys is its own kind of operational overhead. So the goal of this NEP to make it easier to work with a single key and be able to send more transactions at once, we're on board with. As for the details of how to do that, it's still open for discussion, which is why we're talking about it now. So the proposal in the NEP is this idea of having random nonces, where the client is able to generate a random nonce. It doesn't actually have to be true random, but that's a detail. They generate a random nonce, they send it off to the chain, and the way we still prevent replay of transactions is the chain has to remember what random nonces have been used for some period of time. And then after an expiry, it's allowed to forget, and then you could choose to reuse a nonce if you wished. So that's the basic idea there. It's a very elegant solution for clients, right? Because clients actually don't have to keep very much chain state. They do still need to know a recent block to sort of base their transaction on, but otherwise it's just generate a number, send it off. No need to worry about checking what the current nonce is and getting it right. The drawback, though, is it's difficult to put bounds on this kind of thing. How many nonces does the protocol actually have to remember? And how are we making sure that we don't end up in a situation where we are doing a lot of database operations all at once? If we get to a situation where a ton of nonces are expiring all at the same time, and we suddenly have to purge a whole bunch of data out of the database, that could cause some latency issues. Nearcore has seen that before in the past. Talking about this offline with Bowen as well, Bowen pointed out that there's potentially a poor interaction here with the new stateless validation work that's happening.
I believe the solution for that, which is you just have to have non-inclusion proofs on stateless validation. So you basically show the sort of adjacent nonces in the state trie, and then that generates a proof that the nonce doesn't exist. And you don't, therefore, you need to send 2 Merkle proofs in per transaction.
Fair, yeah. Anyways, I say potential interaction. Like stateless validation, of course, is still new. It's not launched yet, so exactly how we integrate with that is not clear. But I guess David already has a good idea for it. So, so that's one side of this. Because there's all this discussion around how we want to handle nonces, I did throw out there an alternative proposal, which was not my idea. It was originally proposed by Jonathan at Aurora. But basically what this lets you do is it lets you have multiple nonces going at the same time. So you have sort of a set of nonces that are allowed to be in flight and they don't conflict with each other. This proposal also has its drawbacks. Basically, in the implementation, it requires the access key that has this type of nonce to be a larger data structure, so you do end up using more storage. It's also not as clean of an interface as the random nonce thing, because you do need to still, as the client, keep some state, right? You still need to know something about what nonces have been used. It also has a maximum throughput. Like a parameter of the design is basically how many transactions you're allowed to have in parallel at once before they start conflicting with each other. So there's trade-offs there. The main advantage of it, though, is that it does have clear bounds because it's based on sort of the current way in which we do transactions, where it's just a different type of access key that has a different way of checking whether or not a transaction is valid. So you're sort of guaranteed that it is always one state read and write.
So if I could just quickly talk about bounds, if you don't mind me jumping in.
Go for it. No, this is an open discussion, please.
Okay, so on the 2 points is one is the bounded size, and the second one is the amount you'd have to remove each time.
Mm-hmm.
So I guess I would argue if you put a rigorous limit on the expiry time, so a very short expiry time by our normal standards, then the bound on the amount of storage used is the number of transactions that can be done in that time, which is a relatively well-known number. It's sort of 330 times the number of seconds, or 1,000 times the number of seconds. It's a number we know. And in terms of the sort of large number of IO operations, you don't actually have to evict all the hashes each round, provided that you evict more than you create. You're kind of in a pretty good state. So if you keep them around slightly too long, it's not the end of the world. You can have a bounded number while still only, which is, I guess, would be somewhere around double the potential number if you remove at most the number of transactions you can do in a single block times by, let's say, 1.5 or 1.1. So that would give you a bounding on the amount of IO you do to the tri-state. And will give you a bounding, and then you already have a bounding on the number of transactions based on the number of transactions you can actually do. So what do you guys think about that? It's kind of.
I mean, that is unfortunately prohibitively expensive in the current architecture. Just if it's like 1.5 times the number of transactions, we know that it will. In cases where, in the unfortunate case where it's like not being like cached or like cache miss, it can take like 2 milliseconds, maybe even longer for read, and that is that, as we have seen quite a few times, it costs chunk processing to take pretty long time, and that is unfortunate situation that we would like to avoid.
So, okay, interesting. So we're unable to do 300 writes to the trie in a block with current overhead.
I mean, it obviously depends on like the shape of the writes, but given that this is completely random, like people can put whatever, they can like even construct it to cause a lot of cache misses and so on. It's definitely possible that 300 random writes. I mean, I think Jacob probably know this better than me, but it's not ideal, I would say.
What do you think, Jacob?
I mean, we have had, let's put it this way, we have been putting a lot of effort removing as much of the database operations as we can. We've implemented prefetchers that first were just like a hack, and then it was used for more and more and more and more things. And this, if we were to add it, it would probably also need a prefetcher. So we were kind of fetching, this is just talking about the reads, just reading the correct nonce values ahead of time. And can we do it? Yes, probably we can get it to work. 300 additional database requests is definitely not trivial, but probably we can get it done somehow. We are mostly worried about latency at the moment, not bandwidth.
Mm-hmm.
But as we add more shards, bandwidth also becomes more and more of a problem. So that's one side of things. And then with stateless validation, a lot of this will be in memory anyway. And then we are more worried about just the number of try accesses that each need the Merkle proofs included, but we're also working hard to reduce the state witness size. And anything we add on top is just an additional burden. So to summarize my view, we can do it if we need, but if there is an alternative that does not need as much overhead, that is definitely preferred.
Yeah, the problem with writes today is it's really bad because you need to first read all the nodes and then do the writes, and you can actually construct the try in a way that makes it even worse. Like it makes it really, really bad. It's a quite unfortunate situation.
Mm-hmm. Mm-hmm. I guess you'd be somewhat limited by it being a cryptographic hash function, but still you could work away and find some difficult strings in there.
No, we're not hashing the keys, so it's not. We're not the.
No, not hashing the
limited.
Hashing the transactions. So storing the transactions with the random nonces and the hashes.
Yeah, but the random nonce, it's random. Or it's like you don't like people can put whatever in.
No, but that is true. But you don't store the random nonce. You store the hash of the transaction that contains the random nonce. Now, obviously, you have the ability to craft that transaction. I'm just saying, it might be slightly harder to make a really nasty request.
Yeah. Okay. Yeah. But yes, but yeah, even I think even without malicious attacks, it can be pretty expensive.
Mm-hmm. It's expensive if it's used. That's
Okay.
Right. Yeah. I mean,
Yeah, I mean, one way to fix things that are expensive is to make sure that people have to pay more if they are using the feature, right? Kind of as an alternative approach would be like, hey, if you're using the nonce feature, suddenly you have to pay whatever 5 times more gas, 10 times more gas for this. Which of course,
fixed overhead, yeah.
Which in theory should cover all the pessimistic scenarios there. And it's kind of, then it becomes a business question of, does this feature still make sense if it costs whatever 5 times more? Would people or the app still use it?
Awesome.
Yeah, I mean, one thing I would say, like Martin, is like you would be surprised by the level of undercharging we see, like with storage, right? I think 5x is probably not even enough. Yeah, but I mean, I think, I think the problem is that it's like just pretty difficult to deal with the storage, right? And then as Jacob pointed out in the stateless validation, or then the problem shifts towards the witness size and so on. But I mean,
you need 2 Merkle proofs. That'd be in a pathological case.
Yeah, I mean, I think it's the proof,
per transaction.
Yes, which is not ideal, I suppose. I mean, I think the idea that Michael mentioned would have lower overhead overall to the system. I mean, it would not work as well for the users who wish to send transactions because it naturally limits the how parallel you can make how much parallelism you can have. But I think if we want to do something with nonce, that would definitely be a change that would be, I mean, probably easier to implement as well, but definitely put less strain on the protocol.
Mm.
And David, just out of curiosity, like what level of parallelism? Because I assume when you were making this NEP, you had a particular pain point in mind, like a particular project that you were having a difficulty with keeping track of nonces, and yeah, what level of parallelism do you think you actually need to have this issue be effectively resolved for most use cases?
So the most obvious pathological case is sweat running a relayer. So I think you could reasonably say that's going to be sort of 300 transactions a second. I guess the difficulty is that, like, when you plan ahead and you know your things need to scale, it's I wouldn't say it's easy to do. We've lost lots of engineering time on it. The difficulty is when you have something that's going quite slowly and it works well, and then everyone lands on your website and the thing just immediately falls over, which is kind of what we see more commonly. So yeah, I think saturating a shard is something we will see relayers do pretty soon. And that's certainly a pain point. But generally, yeah, it's any wallet interaction. We see it as a large source of our errors, even in relatively simple actions, actually. Just people try and do two things at once in the interface over a slow network connection, and something silly happens.
In fact, I would take the conservative approach. Like, if we had something like this, I would encourage us to actively, like, if you're not using if we had this feature and you weren't using it, we should reject any transaction if you have a transaction in flight. Because if we don't, then your ability for the transactions to get included with your current application architecture is by luck and not by and not deterministic.
Mm-hmm.
And so yeah, it's more like everybody who does not explicitly serialize all their transactions is running that risk when their application gets some usage, or when their wallet gets some more usage. And I would love to make that actually more explicit, but there's no alternative right now.
I guess so. One thing I guess I'm not entirely following is, with the alternative transaction, don't you also write the try each time you mutate the bit set?
Yes, but it's basically the same as the current status quo, in the sense that in the current access key model, you're just writing the new nonce, whatever one you just used, that sort of like updates in place. Now it's going to be the same kind of thing, except what you're updating in place is the bit set. So
I guess so. If we sort of got rid of the other nonce, wouldn't you have the same number of writes and reads?
if we
have to do one write and one read to the bit set per transaction, or one write and one read to the nonce sort of incrementing value currently, why could we not do one write and one read to a crypto hash? Why is that so much more expensive?
Because it makes the try much deeper. It creates the subtry that makes it. It's not actually a one-to-one translation like this. That one read or one write translate to potentially like 20 read of storage node, which then translate potentially to like 400 actual database reads.
Okay, that makes sense.
Yeah, like with the alternative solution by, I think, Michael and others kind of proposed it, we only touch the struct that holds information about the access key. And that thing we're already touching, we're already reading it, we're already modifying it anyway. And how much you change internally doesn't really matter. It's the same workload for the DB. But if you have something else somewhere else in the try, then that adds a lot of additional work.
Awesome. Thank you so much, everyone, for sharing your opinions. Great. So now that we've heard about the benefits and the concerns of NEP-522, I would like to point out that based on the NEP process itself, we will not be able to proceed with this NEP because it didn't pass the subject matter expert reviews. So therefore, it will be rejected. Okay, great.
But I do want to still say that even though this particular NEP is sort of, must be closed because process constraints, this is like, we're following the process, this is what we must do. I would still like to see another NEP related to transactions opened up. Like, I don't think this should be the end of the conversation on this topic. So yeah, for what it's worth, I think we should still see more work on it.
I guess I'm just going to say, like, just as a comment on the process, I find it very, very difficult to do complex NEPs when I'm not a protocol engineer. Because kind of the problem I run into is I say, like, look, here's a problem, here's a solution that makes sense on the API side. And then what I run into is like, it's a bugger to implement. And that's kind of, it's a very, in some ways I wish the NEP process was a bit more like, here's a real problem I have, and here's what a great solution would be. And then maybe sort of have a different step, which is how do we implement this? And I understand they're sort of connected in a lot of ways, but it makes it, I think there are probably not that many NEPs that make it through that are not from protocol engineers. And it might make it seem a tiny bit exclusive. But I appreciate how open-minded everyone was in the school. That's
Awesome. Thanks so much, David. Thank you, everyone, with your reviews. So moving on to Q&As, does anyone have any questions they'd like to ask?
Yes, thanks, David, for the feedback on the NEP process. I think the suggestion, basically like kind of like an RFP suggestion, is it's definitely a valuable one. I think it's we don't have a formal process for that at the point, but I think there are people who like open up issues on the NEP repository and basically kind of feature wish list or something like this, something that they wish to be done. But I think the NEP process itself is designed to actually have this very rigorous review process of changes to the protocol. That's why it has a lot of steps, and it takes a long time potentially, and people will point out problems in the proposal. I think the idea is that changes to the protocol are potentially, or like maybe all of them are dangerous in one way or another. So we want to make sure that they actually would be beneficial for the operations of the protocol, but also beneficial to the ecosystem as well. So yeah, I think I on the nonce topic itself, I do think that the current status quo is quite suboptimal. It causes a lot of problems, and it should be fixed. I think the problem, the question here is that what is the right way to actually fix it, and that kind of balances the user demand and also like what actually works well for the protocol. And then I think that's a difficult question to answer.
yeah, I guess I'd like to come back to this at some point, and start by charging a lot for it. If it is expensive, I think we should charge for it. I think there is demand, and I think almost every application that is currently used by a lot of people will fail under load, which is a real problem.
Right. But what is the what is the problem you see with the idea that Michael mentioned? Is it like the throughput would be concerned?
I think it's pretty tricky to use, would be my guess. And I think it would once again scale to a certain point. And then the day when 500,000 users drop on your site is the day it just falls over. And it will also probably lead to sort of long tail unreliability. Like I think it's a little bit dangerous because it's pretty good. That's kind of my problem with it. It's sort of about, it's if you do it randomly, it's about, it was 256. It was like 15 times better than it currently is if you pick randomly, and it's 256 times better if you pick in the correct order. But once again, I think it will fail under load, and I think we get a lot of complaints in our about unreliability of the protocol. And it isn't the protocol that's unreliable, it's people's interactions with the protocol that fail under load. And I think the difference between the perception of an unreliable protocol and an unreliable protocol is almost meaningless.
Yeah, I'm trying to think what that. But I mean, assuming like we implement that idea, right? I assume that there will be API implemented on the client side SDKs that provide interface to that, so that it's relatively easy for people to use.
Yeah, it's just that in a lot of use cases, people are using the same set of keys, but they're using two different clients, and they sort of hit the same keys and do the same thing. So we can write clients that manage it correctly, but if they copy the key using it in two different places, ingressing over, there's 4 different servers running. There's kind of not that much we can do, and that's very
no, I agree. But
I'm okay with that. Like every EVM chain doesn't support that cleanly. Like that's. I think if we can at least make it, if we can at least get to a place where you have a really good sense of how whether your parallel transactions or simultaneously running which transactions will succeed or fail for a single client, like that's still leaps and bounds improvement.
Yeah, that is.
Yeah, and also I would argue it seems to me a bit weird that the same key pair would be used on multiple different clients. That sounds like not a great security practice.
It's
in the first
client libraries, so it's people calling into the wallet from multiple websites on a shitty internet connection. It's a classic. And I guess the wallet should contain the nonce status, but they tend not to. The nonce is generally fetched elsewhere.
I see. Okay.
Awesome. All right. So yeah, thank you to everyone involved and present on the call. We're very excited to work together and decentralize the development of NEAR. But yes, very quickly before we close up the meeting, I want to quickly highlight the ways you can get involved in the NEAR developer ecosystem. To everyone watching on YouTube, if you have an idea in mind, feel free to submit it using DevHub, or you can find any of the other existing communities to collaborate with. You can also submit your own NEP, and you can view all the NEPs and check out their updates on GitHub in the discussions. You're also very welcome to join our community Telegram. It's a great way to connect with others and see announcements for meetings like this. Wow, that was just a lag right there. But yes, you can also learn about DevHub on our website and stay up to date on our social channels. I'll post the recording for this meeting and upcoming calls on all the other channels as well. So yes, thank you everyone for showing up. Thanks Eric, David, Jakob, and the working group members. Really appreciate your time. And yeah, have a great rest of the day and a wonderful weekend.